So in this video, we're going to talk about how do we actually distinguish between resonance or identical structures, right? Pretty much the same thing, from constitutional isomers, as well as can we tell if they're just unrelated, right? So we're going to go through a series of problems, and we're going to say, okay, well, are these really identical or resonant structures, constitutional isomers, or unrelated, right? To kind of test your knowledge. So use this video to kind of test your knowledge um, of how well you understand the material. Now, I have the first two structures. So these are two structures, right? And so my question to you is, are these identical or resonance? Are these constitutional isomers? Or are they just totally unrelated? So the first thing I like to do is to check my molecular formula, because I could pretty much rule out I could pretty much tell the difference between if they're unrelated or they're constitutional isomers just by the molecular formula. So what do I mean? If I look at this compound, I have 1, 2, 3, 4, 5. So I have 5 carbons. So this is actually C5. And how many hydrogens I have, right? Remember, in organic chemistry, I did not specifically give you the hydrogens, but you should know that there's 2 hydrogens here. There's 1 here, so that's 3. There's also 1 here, so that's 4. There's 2 here, so that's 6, and then there's 2 here, so that's 8, right? So my molecular formula here is actually C5H8. Now, how many carbons? Let's draw the molecular formula for this, right? Obviously I have carbons, but how many do we have? I see 1, 2, 3, 4, 5, right? Remember, there's a triple bond there, so this is actually 5 carbons. Now, how many hydrogens do I have? Well, these are 2 methyl groups, so this is essentially 6 hydrogens, right? Remember, I have 1 hydrogen here, right, coming out of the plane, right? So that is 7, and then I have an additional hydrogen at the terminal carbon, right? So this is C5H8. So immediately, you can see that these are the same molecular formula. I have the same molecular formula, which means that they cannot be unrelated, right? Unrelated just means that we have something that's totally different. So the answer now becomes, okay, well, are these constitutional isomers, are they identical or resonant structures? Right? And these are your classic constitutional isomers. Why? The definition of a constitutional isomer says that I have the same molecular formula, I'm just different in the atom connectivity, right? I'm just different it's just different with respect to the atom connectivity. Why couldn't it be identical or resonance? Well, there's no way I could take this ring and actually draw any resonance structures to get this, right? It's just impossible, right? So we say that these are classical constitutional isomers. Let's go to the next problem. Whoa, this one is interesting. All right, so pause the video and actually answer this question. This one is interesting. What do you think? Are these identical or resonant structures? Are these constitutional isomers? Or are they unrelated? Well, like I said before, the first thing I'm going to do is always draw my molecular formula, right? So I want to know what my molecular formula is. So how many carbons do I have? I have 1, 2, 3, 4. So I have 4 carbons. So this molecular formula is C4. Okay, how many hydrogens do I have? I have 1 here. I have 1 here. I have 2 here, so that's 4. And I have the last one here, which is 5. So this is C4H5. But I also have oxygens, and you could clearly see that there's 2 oxygens in the formula. What about over here? I have, how many carbons do I have? I have 1, 2, 3, 4. Right? So 4 carbons, so C4. How many hydrogens do I have? I have 1, 2, 3, 4. Right? This is 4 carbon, right? We got to get, I'm not drawing my hydrogens in, but you got to get used to organic chemistry being like this, right? Right. So essentially we have 5 hydrogens again. All right, so this is 4 plus the hydrogen right here, so that's 5. And obviously we have 2 oxygens. So we have the same molecular formula, So so pause the video and answer the question. Are these identical resonance, constitutional isomers, and are unrelated, right? Again, they can't be unrelated, right? And so I'm going to give you the answer now, but they can't be unrelated, obviously, because we have the same molecular formula. So I'm going to write that these are actually constitutional isomers. And if you think that way, you are incorrect, right? The answer is actually resonance structures or identical. This is the actual answer. Now let's talk about it for a minute. You might be saying to yourself, wait, we have the same molecular formula, but why aren't these constitutional isomers? And the idea is, remember we said earlier that constitutional isomers is the same molecular formula. However, the atom connectivity is different, right? Here, the atom connectivity is the actual same. I have my oxygens in the same realm, right? They're not connected any different. The only thing that actually changed in this formula was the electrons. So that is a critical distinguishing factor, right? Atoms versus electrons. So essentially, what I'm saying is that, and let me draw this. I'm going to draw this up here. So let's prove why these are actually resonance structures. Now remember, I have two pairs of lone pairs on the oxygen, right? And I forgot my obviously double bond, right? Now I could take one of these lone pairs and actually bond it uh, to the adjacent to the carbon adjacent to the oxygen. At this point, obviously carbon can have five bonds, I'm sorry. So I could take this double bond and put it on the other side. At this point, now I'm giving carbon five bonds again. Actually, I could actually take this in the part in the form of lone pairs now and put on the oxygen. And so if I look at where my electrons are going and we redraw the structure, now I've took one of the lone pairs off. So now this oxygen now has one lone pair. I have a double bond here. That's where my arrow is pointing. Also, I have a double bond here. And now I've taken one of these double bonds and put in the form of lone pairs on that oxygen. So essentially, I have this. And this is the exact same structure that we see here, right? Now my oxygen has a positive charge, right? So it's very critical for you to distinguish between atom connectivity and electron moving. All right, let's look at another one. Pause the video and answer the question. Are these identical or resonance? Are they constitutional isomers? Or are they unrelated? Right? Well, the first thing I like to do again is actually get my molecular formula. That's the base. That's the easiest way to start off these problems. So I have carbon, but how many carbon do I have? How many carbons do I have? Right? I have 1, 2, 3, 4, 5. So I have 5 carbons. So this is C5. How many hydrogens I have? Right? We got to get used to seeing this, right? There's 2 hydrogens here. There's 2 here. That's 2 here. That's 2 here. And that's 2 here. Right? So that's 10 hydrogens, but I have 1 also here. So this is C5H11N. Right? I only have 1 nitrogen in the formula. How many carbons do we have in this formula? We have 1, 2, 3, 4, 5. So this is C5. How many hydrogens? Now something different, right? I have 1 hydrogen here. 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 I have 1 here, and obviously this one, right? So this is C5. So this is C5H6, right? So this is C5H6. I'm sorry, C5H6. All right, so this is C5 H6. And immediately we could essentially stop. We have a nitrogen here, and that's the only nitrogen, right? But these are not even the same compounds, right? Two different molecular formulas. So we say that these are unrelated.